Hello everybody, Mr. Delgado here. Today we're going to be covering Unit 2.3, Uncertainty in Data. The main idea for this unit is that measurements contain uncertainties that affect how calculated results are presented or is presented. So what this means is that when they're presenting results from an experiment, you have to really be careful that you understand how they measured the error. Depending on how they measure the error, the experiment can be really impactful or not so impactful. And the error value is really important when you're kind of analyzing what they got out of an experiment. The essential questions for this unit are: how do accuracy and precision compare? How can the accuracy of data be described using error and percent error? What are the rules for significant figures, and how can they be used to express uncertainty in measured or calculated values? The new vocabulary that we're going to be talking about in this unit are accuracy, precision, error, percent error, and significant figures. Accuracy refers to how close a measured value is to an accepted value. What does that mean? So an accepted value is something that's kind of been established, or maybe something that you expect, or something that is almost a certain for being correct. And so when you're really accurate, that means that you're getting really close to what you expect or what you want. Precision refers to how close a series of measurements are to the other ones, or other one. So, now, what does that mean? That means that you can be really precise and not be accurate. So the numbers can be the same or really close to each other, which is good, but they might not always be accurate. So in the best case scenario, you want to be accurate and precise, which means that your numbers are really close together all the time in multiple experiments, and that they're close to what the accepted value is. Error is defined as the difference between an experimental value and an accepted value. And this is a really important definition because when you're measuring error, you want it to be close to what it should be, not what it shouldn't be. The error equation is error equals experimental value minus accepted value. That's the general equation for error. So when they're talking about percent error expresses error as a percentage of the accepted value. So what does that mean? That when you're calculating percent error, it equals the absolute value of the error, which means the positive, over the accepted value times 100. And the reason that you're taking the absolute value is because error can have a negative value, but percent error always has to be positive. These are a few examples. When you go through these, you can go through these on your own, and if you have any questions, you can always email me or contact me or come to the PBL, and I can walk you through these if they don't make sense. These are really good examples, and they start off with the general process of problem solving where you identify the knowns, the unknowns, you state the equation, and then you start solving it. And there's a couple in there, I think. So often precision is limited by the tools available. Significant figures include all known digits plus one estimated digit. So what does that mean? That means that there's different tools when you're measuring things, and that every tool you use to make a measurement of any type always is going to have some unit of error, which means that there's always going to be a little bit of wiggle room in the numbers. And so significant figures are really important because they let you identify which numbers are the important numbers and which numbers are the numbers that you really have to pay attention to. And so the general rules for identifying significant figures are as follows. And these rules are something that's really important because when you're looking at numbers, and especially like for ACT prep and for college test preps, they are really, really picky on making sure that kids understand significant figures because it tells you which numbers are actually important. So I'm going to just kind of run through these rules right now. So rule 1, non-zero numbers are always significant. So that means if it's not a zero, they're significant. Zeros between non-zero numbers are always significant. So that means if there's a zero in between two numbers that are not zeros, those are significant. All final zeros to the right of the decimal are significant. Placeholder zeros are not significant. To remove placeholder zeros, rewrite the number in scientific notation. So placeholder zeros are really easy to get rid of because if you go back and just write the number in scientific notation, that means that it's all those zeros at the ends. And then rule 5, counting numbers and defined constants have an infinite number of significant figures. So that means that when you have like counting numbers, which are general numbers like 1, 2, 3, 4, 5, 6, 7, they have an infinite number of significant figures because they're big. They're big numbers. That means that they have a bunch of significant figures. And if that gets confusing, you can always email me or you can come to the PBL and I can explain that further. Or contact me in the Google Classroom. There's an example in here about significant figures and multiplying numbers, rounding and multiplying. So these are really great examples. When you walk through them, they start off with a lot. They start off with problem solving. So they have the problem, then they have a response, which means that you're going to analyze the problem, which is really a good way to start problem solving, and they should teach you this in your math classes. So when you have a problem, you analyze it, and you kind of figure out some key points about the problem really quickly, and then you identify the knowns and the unknowns so that you know what you're solving for, and then you solve for the unknown, right? You write out the equation in words, usually. Then you write out the equation with numbers. Then you solve for it and you make sure that you put the units. Now, especially in the chemistry class, the units are very important. So make sure that you always include the numbers, the units with the numbers. Because in this class especially, usually what I do is I kick stuff back if it doesn't have a unit. Because the numbers, the important part of a number is really the unit and understanding that the number and the unit. And then, of course, at the end, you always want to have an evaluate the answer, right? So you always want to make sure that your answer makes sense. And in your math classes, sometimes they make you go back and check things different ways. You can do that in this class too in a lot of cases, but the number just has to make sense. So if you solve a problem and you're coming up with a really huge number for a unit that should be smaller than another one or bigger than another one, you know that there's a problem. And that's really what that's talking about. So there's a couple of these examples. And in this examples, they're going to be talking about significant figures. And on these ones, they'll just go through the rules. And they'll say which rule they use to make the note, to identify the significant figures. Which is really a good example. Rounding numbers. Now, most people know how to round numbers, but identifying significant figures also helps you with that. Rounding numbers, addition and subtraction. Rounding numbers, multiplication and division. Now, both of these involve identifying significant figures. And there's some examples of these. So if you have any questions about any of this material in this unit, you can always email me. You can call me on the phone number that I provided for this class. And you can contact me in Google Classroom or come to the PBL. I hope you all have